Hey everyone, welcome back to section 9.3. Today we're going to talk about the area of circles. We're also going to talk about the circumference of circles as well in this section. So we'll jump right into our formulas here. A circle with diameter length d and radius length r has circumference of pi times diameter or 2 times pi times radius, and an area of pi times the radius squared. Okay? Little note here, if we're given the diameter of the circle, how do we find the radius? Well, we know that the radius, there's 2 radii in every diameter. If you look at the picture here, 1 radius, 2 radius, right? So if 2 radii are giving you 1 diameter, then 1 radius would be the diameter over 2. So if we have a diameter and we want the radius, we simply cut the diameter in half to find the radius. So here's a couple examples. If a diameter is 24 inches, that means the radius is 12 inches. If a radius is 10 feet, the diameter is 20 feet. If a diameter is 50 centimeters, the radius is 25 centimeters. And if a radius is 17 centimeters, the diameter is then 34 centimeters. So if you have the radius, we double it to get the diameter. If we have the diameter, we cut it in half to get the radius. All right, let's jump into some problems here. Find the area and circumference of circle K in terms of pi, and then also round it to the nearest tenth. So first of all, in terms of pi, that's another way of saying exact form. So when you see that, all we're going to do is just not type the pi into our calculator, but we can use everything else, and then the answer will have pi in it. And then rounded means we just type everything to our calculator and give what the answer gives us to the nearest tenth. All right, so first of all, here's our circle. We see that the diameter is 6 inches. If we cut that in half, we know the radius is 3 inches. So now we can go ahead and use our formulas. For the circumference, we can use pi times diameter or 2 times pi times r. It doesn't matter which one. I'm going to use 2 pi r, which means our circumference is 6 pi. Circumference is a linear first dimension measurement, so it just gets a first dimension unit. So 6 pi inches is the correct answer. That's the answer in terms of pi. And then if we want the rounded answer to the nearest tenth, we simply type 6 pi into our calculator, and we get an approximation of 18.8 inches. So 6 pi is approximately 18.8. And then for area, we know our area formula is pi r squared. 3 squared is 9, so our area is 9 pi. Units would be square inches because area is a 2-dimensional unit. And if we want to round that to the nearest tenth, we can type that into our calculator, and that would give us an area of approximately 28.3 square inches. Question B, find the radius of circle J if the circumference is 18 pi, then find the area. All right, so they give us circumference is 18 pi. Let's write that down. Circumference is 18 pi. And we know the formula for circumference that we just used is 2 pi r. So 2 pi r equals 18 pi. Now if we divide both sides by pi, we're left with 2r equals 18. And if we divide both sides by 2, that gives us r is 9. Now I can go ahead and use my radius to find the area of the circle, pi r squared. So our area is 81 pi square meters. And if you want a rounded answer, you can type 81 pi into a calculator, and that'll give you approximately 254.5 square meters. Part C says find the circumference if the area is 25 pi square feet. So now we know the area is 25 pi. So let's write that down. Area is 25 pi. And we know our area formula is pi r squared. All right, if we divide both sides by pi, the pi's cancel, and that gives me r squared is 25. Taking the square root of both sides, we know that r must be 5 feet. So then we can find the circumference by putting 5 into our 2 pi r formula. And our circumference is 10 pi feet. And if you want that to the nearest tenth, type that in your calculator, you would get 31.4 feet. Now we're going to talk about a piece of the pie, a piece of the circle, which we call a sector. Okay? A sector of a circle is a region bounded by 2 radii of the circle and the intercepted arc. So in the figure there, that orange colored in piece of the pie is called a sector of the circle. All right, so how do you find the area of that? Well, it's actually really easy. You take the area of the circle, and then you multiply it by the measure of the arc divided by 360. Why 360? Because 360 is the measure of the whole circle, right? So it's just our area formula, and then you multiply it by the measure of the arc over 360. Little hint there, to write the degree symbol after m in the formula to help you remember to use degree measure, not length. Measure and length are 2 different things. We haven't learned length yet. We will in about 2 minutes here. So first, let's find the area of a sector. All right, so we want this gray sector, JGH. So our area is going to be pi times the radius squared. That's just our area of a circle. But now, just because we want that piece of the pie, we're going to multiply it by the measure of the angle or the arc. Remember, the angle and the arc are the same. And divide that by 360. All right, so the first thing we're going to do is we're going to get the exact answer in terms of pi. So don't type your pi in your calculator. 12 squared times 131 over 360. And if we change that into a fraction, we get 262 pi over 5 square meters. And now if we want our exact answer, we just multiply it, our rounded answer, we can multiply that by pi. And we get 164.62. We're being asked to round the nearest hundredth here. So 62 square meters. All right, at this point, I want you to pause the video and try problem B. Unpause the video when you've completed it and you want to check your answer. All right, so now we're going to take a look at the length of an arc. So we've been working with measure of an arc for the last couple of chapters now. Now we're talking about the length of an arc. So what does that mean? It means if you were on point B on that circle and you wanted to walk to point A, how long of a walk would that be? In inches or feet or miles or whatever. Okay, so arc length is the distance along an arc measured in linear units. Okay, let's take a look at that formula, and you might recognize part of this formula as well. This is just the circumference, right? 2 pi r, that's the circumference. And then once again, we're going to take that circumference and we're going to multiply it by the measure of the arc divided by 360, the full circle. Okay? So here's an example of that. It says find the length of FG. So here's the length of FG right here. We know its measure is 134 degrees, so we got to find the length. So how do we do that? Well, we're going to say that the length is going to be equal to 2 times pi times the radius, because that's the circumference. And we're going to multiply that by 134 over 360. Again, if we want an exact answer in terms of pi, we're going to type everything in except for the pi into our calculator and change that into a fraction. And we get 268 pi over 45. And the units for circumference are just one-dimensional, so just centimeters. And if we want that in a rounded form, we can multiply that by pi, and that would give us 18.71 centimeters. Once again, please pause the video at this point to try question B. All right, there's your work and answers for part B. Which brings us to the last slide. 2 more practice problems I'd like you to try. The first one, make a little change there. We're going to make the diameter 16 inches, so diameter is 16 inches. And for the second one, just to give you a unit to work with, let's make the radius 12 feet. Okay, so pause the video. Once again, try these 2 problems and come back and unpause when you are complete. And there are all your answers for these 4 problems. That'll do it for section 9.3. Next time we're going to take a look at the area of regular polygons, hexagons, octagons, pentagons, and other shapes like that.